Hey, thanks for watching Extra Practice, or at least inquiring about the video and thinking about doing some extra work to make sure that you are prepared and understand what we're doing in class. So here's kind of the way that I envision that this video would help the most, where you maybe don't necessarily have to do every question, although you are more than welcome to. And I don't plan on going through step by step and explaining every question. So I will explain what I do for the first one, letter A, in each learning target. And then I will show you answers for B, C, and D for the rest of them. So for you to be able to practice and quiz or test yourself the most efficiently, I would first try them all, or the ones that you want to attempt, and then play the video to see the answer. So it's going to be a lot of start and stopping to make sure that you don't see the answer before you try it on your own. That's really how extra practice works the best. You kind of quiz yourself first and then do a self-check. And then if you have it correct, awesome, you move on. If it's incorrect, go back, look at my answer compared to your answer, see where the error is. Hopefully you would be able to find where the correction needs to be made and understand why that correction would need to be made. And if you don't, that's something that you want to write down, take note of, and make sure that you ask me or ask one of your classmates in class the following day. So this is not something you have to do. It's just, like the top says, extra practice. So I did want to put up at the top, though, once again, the learning targets, so that you know what it is that this extra practice is going to accomplish. So we're going to be working on and practicing 3 of our learning targets. And the first one is to be able to identify or list what the terms and the coefficients are in an expression. The second one is to be able to use distributive property and do it in 2 ways. Go from factored to expanded, and then vice versa, go from expanded to factored. And then the third one is to create equivalent expressions, so 2 expressions that are equal to each other. And that could mean using the distributive property, but not necessarily 100% of the time. So don't think that distributive property is the only way to make an equivalent expression. So with that said, let's look at our first learning target, where we are going to list the terms and the coefficients for each expression. So this is how I would approach this, and I will only explain this for part A, is I would box each term. And you do want to include if it's a plus or a minus sign in front of it. And I'm wondering if I do it in different colors, if that will make it easier. So I'm going to include the minus 27. My next term would be a plus 7y. And then my final term would be a plus 3k. So you can see there now that I have 4 different colors. I have boxed 4 different pieces. Those pieces are called my terms. So if I were to make a list, don't leave them boxed. Do make a list. I have 6t, a minus 27, which does really represent negative 27. I have a 7y, and it's fine to do plus 7y, just showing that it's positive. And then I have a positive or plus 3k. So those are my terms. And I'm just going to label them with a T. But the second part of that is to list the coefficients. Remember that the coefficients are the numbers directly in front of a variable. So now looking at my list of terms, I can see that that one includes a variable, this one includes a variable, and that one includes a variable. So the three that I have highlighted are the three that I need to look at. And if I've highlighted 3, that means I should have 3 coefficients. So the number in front of the 6t is 6, so that's a coefficient. I have 7y, the number in front of the y is 7, so that's a coefficient. And then I have the number 3 in front of the k, so 3 is my coefficient. So if part of that, all of that, none of that, if there is still a lot of confusion on that, please make sure you attempt B, C, and D on your own. I'm not going to go through a full explanation in all of them. What I will do is I will box them, but I'm not going to talk through it. So go ahead, this would be a great time to pause the video, because the next time that you start it up, you're going to see each of the answers for B, C, and D at one time. All right, here are your answers in my lists for B, C, and D. And as I was going through, I told you I wasn't going to say anything, but a couple things popped up that I hadn't really thought about that I want to make sure that I draw to your attention. And part of that has to do with letter B. There are 2 things. You have 2 terms that include the variable L. Make sure they are listed separately. I boxed them in 2 different boxes, and they were boxed in 2 different colors. So that does mean they are 2 separate terms. The second thing, which I want to make sure that you understand, is here the coefficient. 2 of those variables ended up having a coefficient of -6. You must write that number down twice. So even if it repeats, please write it down as many times as you see it. And the second thing is, don't forget about the coefficient of 1, which connects to the singular variable L. So go through, pause it if you need to double check your answers, and then when you're ready to move on, I'll have the explanation for Learning Target 2, Part A. All right, so Learning Target 2, we are working with distributive property. And the first part of that, so it's really Learning Target 2A, right here, and then we'd have Learning Target 2B. So Learning Target 2A is we're going from factored to expanded. That means in factored form, it is the shortest way to write it. And you will always have a number or a variable that is outside of a parenthesis. And when you expand it, that means that you take what's outside the parenthesis, like this x, and you need to share or distribute with whatever is on the inside. And since the x right here is squished right next to the parenthesis, anytime that something is squished next to a parenthesis in math, that means multiplication. So if the x is shared with a 2, to expand it out, that means it's x times 2. We use the same operation sign that is inside the parentheses. We happen to have a plus sign, so that means I'm going to have to put a plus sign in my expanded form. So I'm going to have x times 2 plus, and then I have to do x and share it with the 3. So I have x times 3. Now it's fine to leave it this way, but hopefully you're starting to catch on that in math we like to use the idea of a coefficient. So generally we put the number first and the variable second. So x times 2 becomes 2x, and x times 3 becomes 3x. So the best way to write it is right there, and that is expanded form. So it does not matter if the variable or the number is on the front or the back side of the parenthesis. it always needs to get shared with whatever is inside the parenthesis. So go ahead, pause the video, try B, C, and D, or whatever it is that you want to try to feel comfortable. Pause the video, and when you come back, you will see the answers and how I solved for the remaining 3, B, C, and D. All right, you can see my answers for B, C, and D. You may need to pause the video in order to take some time to double check my work there, because I am going to move on now to show you the expanded form to factored form. All right, so expanded form to factored form. Now we're basically going to go the opposite way, and we're trying to make it as simplified as possible, and we're going to put the parentheses back in. So in order to do this, in each one of these options, you need to look for what it is each term shares. So here we get to do a little bit of review. So in example A, I have a term 2x, and I have a term 4x, or a positive 4x. So you might have already picked it out that the two things that they both have in common is that variable x. That means that that variable is what's going to go on the outside of the parenthesis. Then we look at, once we take that part of the term away, what we have left. Well, in the term 2x, once I take x away, I have 2. I always include the same operation. And then once I take the x away in the term 4x, what I have left is 4. So that means I have gone from expanded to my factored form. So go ahead, try B, C, and D, looking for what pieces are shared. Pause the video, because once you hit play again, you're going to see the answers. So go ahead and try and quiz yourself first. All right, to help you see the answer a little bit easier, I did go ahead and highlight in the remaining 3 the piece of the term that they both shared. So that should help make a little bit more sense. The one thing I did want to point out is, like in B, where it has this multiplication sign, the reason that the subtraction carries over between the parentheses is because it's right here where the multiplication is happening, because the number is squished right next to the parenthesis, so that is already taking care of this multiplication right there, so you don't need to add it anywhere else. Pause the video if you need to double check your answers, because once you hit play again, you're going to move on to the last learning target. All right, learning target number 3, the final for this extra practice video, where we are going to create equivalent expressions. Now, each one of these is a little bit different, so I'm going to talk through them. So if you want to speed it up or slow down the video or rewatch a section, that's perfectly fine. So in this first one, I have n plus n plus n minus 7. So if I want to create an equivalent expression, there are 2 things that you can ask yourself. One, how can I make it shorter? Or in math we say simplify it. So what can I combine? The second thing is, you might think about, well, how could I actually make it longer? Which would be putting it in more of an extended form. So when creating equivalent, you're always going to look for ways to shorten it up, or the opposite, ways to make it longer. In this first one, all my variables are written separately. So to make an equivalent expression, I can shorten it up and I can combine those. So because I have 3 n's to make an equivalent expression, I'm going to say I have 3 n's minus 7. and I have just created an equivalent expression. For part B, I have parentheses, and notice that there is a number sitting outside my parenthesis. That should automatically kind of trigger this idea to need to use distributive property. So I'm going to, distribute or share what's on the outside with what's on the inside. So it's currently factored, so it's as short as it can go, and I am going to now put it in expanded. So I'm going to have 4 times 2 plus 4 times 6h. So that is an equivalent expression, but I could also do 4 times 2 is 8, plus 4 times 6, 24, 24h. So in this case, either one would be an equivalent expression. All right, let's look at part C. I have 2k plus k. There are really two options that you have here. Option A is to make it as expanded as possible. To do that, I would separate out each k that I have. So the 2k, I would actually write out 2k's and then just do the plus k at the end. Or I can make it as short as possible. I have 2k's plus another k, which gives me a total of 3k. So that is also an equivalent expression. All right, in part D, looking at that, after our work with distributive property, I would hope you could kind of recognize that each term, I have a 5 in it. That means that to create an equivalent expression, I could go from expanded to factored form, because when they share something, I can put it on the outside of the parenthesis. And I use the part that's left over. That means I have a t, my plus sign, and the number 7. And I have just created an equivalent expression. One other thing that you could do is going back to the original is to say, well, 5t, leave that alone, plus, and actually multiply out the 5 times 7. So I would have 5t plus 35. So oftentimes with some of these creating equivalent expressions, there's more than one way to represent the exact same idea mathematically. It just looks a little different. So E, we have that number outside the parenthesis. I'm going to go ahead and use distributive property, share what's on the outside with the two pieces that are on the inside. So I have 3 times 2L plus 3 times 4. That's one option. And then I can combine some of that a little bit. 3 times 2, that means I have 6L plus 3 times 4 would give me 12. So both of those are perfectly acceptable answers for equivalent expressions. Now this last one, a little trickier because it's not as obvious as, say, what it is in example D, but I included this so that you would know that this is a possibility. We need to put this option into factored form, which means I'm going to have a number outside the parenthesis and two things inside. I already know it's going to be plus because of that. And they don't both share the variable k, so I know somewhere there's going to have to be a variable k inside. Can't be on the outside or they both would have to share it. So you need to ask yourself, what is it that 5 and 15 have in common? Well, I know that 5 is a factor of 15. So if I put 5 on the outside, what would I have to put here to get to 15 if I share it? Well, that would have to be 3. Because remember, when we share, it gets multiplied. So 5 times 3 would be 15. And then 5 multiplied by k, well, I can just leave it. Because 5 times k is 5k. So without all that extra in there, it's 5, 3 plus k. And that's more of an advanced example where you're factoring something out of two of the terms. So if f is something that is way over the top, you're really struggling with f, but you're beginning to understand the other ones, do not worry about it. F is just for those that can see that, because you will work on that type of distributive property in 8th grade. It is not something we will necessarily work on right now. Hopefully you found this helpful. If you would like to see more extra practice videos like this that you could watch or quiz yourself, test yourself, please let me know. I'd be more than happy to put anything together for you guys.